Hi everyone, in this video I'll be discussing pH and what is the importance of pKa. Now, we had this discussion in general pharma, that is in pharmacokinetics, but why we have taken this separately? Because you need to understand the concept in a better manner. Now, what we told in absorption part is if you place a weakly acidic drug, if you place it in acidic medium, we know that weakly acidic drug, if you place it in acidic medium, the drug will be lipid soluble. That means it is non-ionized. So if it is non-ionized, it can easily cross the cell membranes, and what happens? The absorption increases. So there is increase in absorption. So we know the general concept like this. Same thing, if you are placing a weakly basic drug, if you are placing it in a basic medium, also called as alkaline medium, so what happens is similar thing. So the drug will be lipid soluble, that is non-ionized, cross the membrane, and there is increase in absorption, correct? So based on that, I had asked you a question. Suppose you take the example of aspirin and morphine. So aspirin is an acidic drug and morphine is a basic drug. And if I consider the GIT, this is the intestine. Now where is aspirin absorbed from? As per the above understanding, aspirin is acidic drug and the pH in the stomach is also acidic. The pH in the stomach is also acidic. So here it is non-ionized and it is easily absorbed here. Morphine is a basic drug and the intestinal pH is also a bit alkaline. So absorption also increases. The morphine absorption occurs in the intestine. So we know that. With that basic understanding, I want to go further. What is that we need to understand here? Now everywhere we cannot tell the pH is acidic or basic, because in our body, various places the pH is different. Let me give an example. Stomach, if I take stomach, the pH is between 1 to 2. If I take intestine, what is the pH in intestine? It is around 6 to 7.4. So here it is different. If I take the blood pH, the normal blood pH is around 7.4, that is a neutral one. And if you take the cell, inside the cell, the pH is between 6.8 to 7. And if you consider the urine pH, the urinary pH, it ranges from 4.5 to 7.8. So we have various fluid in the body which have different pH. Now when I place the drug in various pH, what happens? How much is ionized and how much is non-ionized? I don't have an idea. So what we have a general idea, if you place aspirin in acidic environment, it will be non-ionized absorbed. But how much acidic? Is it 1 pH, 2 pH, 3 pH, 4 pH, 5 pH? Now what happens if I change the pH? How much is non-ionized and how much is ionized? We don't know. To understand that, there is a value and that is called pKa. In the books they would have given aspirin, which is acidic drug, as a pKa value of 3.5. Okay sir, aspirin pKa value is 3.5. Then what do you mean by that? There should be some understanding. Now the meaning of pKa is a pH. pKa is a pH at which drug is 50% ionized and 50% non-ionized. I'll repeat again. pKa is a pH point. You know the pH range is from 1 to 14. It is the pH at which the drug is 50% ionized and 50% non-ionized. Suppose if I take the pH scale, so pH is from 0 to 14. That is the pH scale. Now usually what we do, we divide it at 7 and below 7 we tell it as acidic, above 7 basic. But here you remember pK is a value. Suppose I write the pK value, this is 3.5. What does 3.5 tell us? If I place aspirin at a pH of 3.5, the meaning is at this point 50% of the drug is non-ionized and 50% of the drug is ionized. So the 3.5 is the pH which is dividing the drug into this point. What is the point? The point where 50% is ionized and 50% is non-ionized. Usually what happens normally, 7 is the dividing point, but here pK will tell us that. Now once you know the basic, let me tell you one more equation. What is the equation? There is an equation called Henderson-Hasselbalch equation. So we have an equation called Henderson-Hasselbalch equation. What does it tell? According to the equation, pH is equal to pKa plus log ionized divided by log non-ionized part of the drug. Now what is the definition of pKa? It's a pH where the drug is 50% ionized, 50% non-ionized. How did we get that? Now what we do is log 50% ionized divided by 50% non-ionized. That means they are equal. So what happens? This one cancels. So what we get is log of 1. So along with that we carry that pH and pK. Now you tell me what is the log of 1? Log of 1 is 0. Log of 1 is 0. So pH is equal to pKa plus 0. So can I write pH is equal to pKa? So pK is a pH where you see the 50% ionized and 50% ionized. So this is the derivation from the equation Henderson-Hasselbalch equation. Okay, so pK is a pH where the drug is 50% ionized and 50% non-ionized. Okay sir, we understood that. Now once we have understood this, let us understand what exactly the meaning of aspirin as a pK of 3.5. What is the meaning of it? Aspirin has a pK of 3.5. What do you mean by that? Now let me draw the pH scale for you. This is the pH scale, and let me draw this. This is the 0. This is the 14. Now what I will do, I will not divide the pH scale with the help of the 7. Now what we will do is we will divide that at what point? The pKa point. This pKa point is 3.5. Now what do you mean by that point? Now this part, what you have written, this part is the acidic environment for the drug. Less than 3.5 becomes the acidic environment for the drug, and this part becomes the basic environment for the drug. But what actually happens when we take the normal pH? 7 is the dividing point, but here 3.5 is the dividing point. So aspirin, if I keep that at a pH of 3.5, it is 50% non-ionized and 50% ionized. Now if I move the aspirin to a pH of 2.5, now tell me, will it be more non-ionized or less? So you are moving acidic drug to acidic medium. You are moving acidic drug to further acidic medium. So it will be around 90% non-ionized and it will be around 10% ionized. If I further move it towards this side at a pH of 1.5, what happens? Now it is 99% non-ionized and then it is 1% ionized. So if you are moving the acidic drug towards the acidic medium, obviously you will see more and more of non-ionized form. Clear? If you still further move into 0.5, so let me take up One more example. If you still move it to the 0.5, how much is non-ionized? 99.9%. And this is the non-ionized part. And how much is ionized? Is around 0.1% is ionized. So this is the point. Okay, sir, we got it. Now what actually happens in the stomach? Let me take the example here. This is the stomach, right? So these are the cells of the stomach. Now when we give aspirin, to the patient, aspirin is in the pH of 1 to 2. So at a pH of 1 to 2, that means between 1.5 to 2.5, you can see maximum drug is in non-ionized form. So aspirin moves easily into the cells. Okay, fine. It has moved inside. Very good. Now what if the aspirin moves towards this side? If I put the aspirin to this side, let us move to the pH of 4.5. Now this 4.5 becomes alkaline environment. This 4.5 becomes alkaline environment for aspirin. So now what happens? The percentage of non-ionized becomes 10. It will be 10, and the percentage of ionized becomes 90%. So it is more and more ionized. If I move another pH, that is around 5.5, it will be around 1% non-ionized. It will be 99% ionized. So if you are moving further, it will be more and more ionized. Now if you know this idea, tell me, if the aspirin moves inside the cell, what is the pH inside the cell? 6.8 to 7. So if you move from 4.5 to 5.5 to 6, the drug is more and more ionized. So when it enters inside the gastric epithelium, that is into the cells, the drug is ionized. Now when the drug is ionized, aspirin cannot move out of the cell easily. So it is called as ion trapping. So because of ion trapping, aspirin stays for a very long period inside the gastric epithelium. So this will lead to gastritis. So patient may have gastritis here. So this is the reason I told you, at various pH the drug acts in a different manner, right? So this is the point, pK is the point where it will tell us what is a acidic environment for the drug, what is the basic environment for the drug. That's it. Now I took the example of aspirin, which is acidic drug. Okay, sir. Sir, you do one thing, you give us an example of a basic drug, then tell us. Now take an example of a basic drug. And this basic drug has a pK of 3.5. It has a pK of 3.5, sir. Okay, sir. Now tell me that. The meaning of that is, if I write a pH scale, this is 0, this is 14, and this is the point, that is 3.5. Now for this drug, this side becomes acidic and this side becomes basic. Now if I move the drug, this drug, before moving, what do you mean by pKa? This is the point where 50% drug is non-ionized, 50% drug is ionized. Now suppose I move this basic drug to one more pH, that is 2.5. Now what happens? Now you are putting basic drug in the acidic medium. So now here you will see 10% of non-ionized, because if you are placing the basic drug in the acidic environment, ionized form is more. So you are seeing ionized form, that is 90%. If you place it in another pH of 1.5, now the drug is 1% non-ionized, but it is 99% ionized. So that's the meaning of, if you place a basic drug In acidic environment, it is more ionized, that is water soluble. But if I shift the drug towards above 3.5, if it comes to the value of 4.5, here the environment is basic for the drug. Now what happens? Now here 90% is non-ionized and 10% is ionized. If I move one more pH, 5.5, it is 99% non-ionized and it is 1% ionized. If I move still 6.5 pH, it is 99.9% non-ionized, 0.1% ionized. So a basic drug favors basic environment. So this is the deep understanding of pH and pK. So simply remember, pK is a value where it divides the pH. So the pH will tell us where the drug has acidic environment, where the drug has basic environment. So that is a point where you have to divide it. So I've given both examples of basic drug. If they have 3.5, what do you mean? And I've also given the meaning of acidic drug, what do you mean by pK of 3.5? So acidic drug in the acidic environment is more of non-ionized form. If you check here basic drug, you can see here as you move towards the acidic environment, it is more, non-ionized form is less, but ionized form is going to be more. So that is a comparison between the pK of various drugs, that is acidic drug and basic drug. So that is in detail for you about pH and pK of the drug. Thank you all.